Okay, today we're going to be doing lecture 15, Exponential and Logarithmic Functions. So last time we learned about equations, and today we're going to be learning about functions. So just to recap what we did on Monday, go ahead and see if you can convert these from exponential form to logarithmic form. And then later on, we'll switch the directions and see if we can go the other way from log back to exponential. But go ahead and try these. I've got 2 to the 4th power is equal to 16. I've got 3 squared is equal to 9. And then the last one we'll do 10 to the negative 2 power is equal to 1 over 100. All right, so go ahead and take a minute and try those. What you're trying to do is you're taking an exponential equation and you're making it into a logarithmic equation using logarithmic expressions. So for a log, you're always going to have a base. You're always going to have a base. I'll write it in blue. And that base is going to come from the base of the exponential expression. So then what you're going to do is you're going to take the exponent, you're going to throw it all the way to the other side of the equal sign. We'll call that exponent y for now. So y is going to be the exponent. And then you're going to have something on the inside of the parentheses, and that's going to be your result or your x. So I'll put that in red. Awesome. There we go. Okay. So now that you've had the time to try these three, let's go ahead and work on them together. What we're going to do is we're going to be taking an exponential expression and we're going to be making it into a logarithmic expression. So I'm going to start off with log, and then my base is going to be the base of the exponential expression, this 2 right here. So I'm going to put the 2 below the g, and then I'm going to have something in parentheses, right? Now I'm going to take the exponent and I'm going to throw it all the way to the other side of the equal sign. So the 4, which is the exponent, is going to show up right here. Log base 2 of what is equal to 4. And then the last number we have, that 16, we call that the result. That's what you get if you raise 2 to the 4th power. We're going to put that 16 on the inside of the parentheses. So what this question is asking is, if you have a base of 2, which exponent do you have to raise 2 to the power of so that you can get to 16? And usually there's going to be a question mark on the other side of the equal sign. That's for you to figure out. So what exponent does 2 need to get back to 16? That's going to be 4, right? Because 2 cubed is going to give you 8. And then if you multiply by 2 one more time, you get 16. And that's 4 of the 2's that you need. So that's where the exponent goes. It always goes on the other side of the equal sign. Let's try number 2. So for number 2, I have 3 to the 2nd power is equal to 9. We can write this as a logarithmic expression as long as we have a base, which is 3. And we're going to have something on the inside. I'm going to take the exponent and I'm going to throw it all the way to the other side. So that 2 is going to end up on the other side of the equal sign, the right side. And then on the left side, I still have room for one more number, and that's going to be my remaining number, my 9. So what this is saying is log base 3 of 9 is equal to 2. It's basically asking, what exponent does 3 have to be raised to get to 9, right? And that would have to be a 2, since 3 squared is equal to 9, right? Okay, let's try the last one, number 3. Okay, so for number 3, I'm going to have a log. What's the base going to be? It's going to be 10. If you remember from our last lecture, we talked about what happens when our base is 10. And when you use the powers of 10, that's called a common logarithm. So we call this a common logarithm, or common log for short. Okay, so what is the exponent in this situation? The exponent is -2. So I'm going to throw the -2 over to the other side. And then what's the last number that's going to go inside the parentheses? It's going to be that 1/100. Or you could also write it as 0.01. But I'm going to write the fraction form. Okay? And that is logarithms. That's what we learned on Monday. Today, I want to talk about functions and the way we graph those functions. So we're going to be using a lot of graphing calculator today. So we're going to be using a lot of Desmos. So if you have that on hand, make sure you're using Desmos for all of your assignments. These functions can be graphed on there, and you can more easily see the attributes that we're going to talk about today. Okay, so on the next slide, what we're going to do is we're going to graph two very simple functions. So I'll give you guys a few seconds to copy this down, and then we'll move on. Okay, so there's always three elements to this, right? A base, an exponent, exp, I'll abbreviate it, and then this x is going to be, we call that the result. So this is what happens when you take the base, you raise it to the y power, you're going to get x. And that's basically how you switch back and forth between exponential and logarithmic. Okay, so on the next page, or on the back of the paper that you're working on now, I want you to divide your paper in two with a vertical line. So let me show you what that's going to look like. You're going to have a straight line going down the middle like this, and you're going to have a heading at the top. So I'm going to draw a horizontal line, and hopefully this will work out for us. Okay, now on the left side, we're going to write exponential function. Exponential function. On the other side, we're going to write logarithmic function. And this is an A, by the way, not an E. I know my A's tend to look like E's a whole bunch of times, so everybody wants to be a complainer. Okay, so we're going to do our exponential function on the left side, and we're going to graph our logarithmic function on the right side. And here are the two functions that we're going to be graphing today. We're going to have f of x is equal to 2 to the x power. So our base is going to be 2. We're going to keep it really simple today. And on the other side, we're going to be graphing g of x. Now this log function is going to have a base of 2. And then I'm going to have x inside parentheses. Now you're probably asking, where is the y? If we have a b and an x, where's the y coming in, the exponent? That's going to be g of x, actually. So you can think of g of x as another way of saying y, because they're basically the same thing. Okay. Let's start off with the exponential function. And what I'm going to do is I'm going to draw a chart. And I'm going to put all the x values on the left side. So put an x right there, and all the y values are going to be placed on the right side. And we'll keep it simple. We'll use numbers that are pretty close to 0 for our x values. So we're going to have -2, -1, 0, 1, 2, 3. And then maybe we can keep on going to 4 if necessary. But I don't think that'll be necessary. Okay. So with those x values, what we want to do is we want to plug every single one of those in for x and see what we get. So if we plug in a 1, we get 2 to the 1 power, which is just 2. So next to this 1, I'm going to put a 2. That's going to be the y value. What happens when we plug in a 2 for our x value? We get 2 squared is equal to 4. So I'm going to put a 4 right here. So now you know what you're doing. You're putting in x values and seeing what the y value is going to give you. If I plug in 3, I should get 8. And now let's do the 0. If we plug in 0, we get 2 to the 0 power, which is just 1. Anything to the 0 power is 1, except for 0, of course. All right, now with the negative exponents, that's when you start getting into fractions. So if I plug in a -1, I get 2 to the -1 power, right? That's going to be 1/2 to the +1 power, which is just 1/2. So I'll put a 1/2 right here. And then 2 to the -2 power is going to give me 1/2 squared, which is 1/4. So we'll put a 1/4 right here. Okay, so those are just a few points. You know, we can get as many points as we really want to, but for this case, we're just going to plug in these 6 points right here. So let's go to our graph. I'm going to pop on over to Desmos. Let's see. There we go. Okay. So now what I want to do is I want to graph all those points. So what I'm going to do is I'm going to move down to number 2, and I'm going to start right there because I'm going to put the function actually in the number 1 spot. So let's graph those ordered pairs. The x values are going to go on the left side, and the y values are going to go on the right side. So if we plug in -2, remember how we got 1/4? So there's that point. If we plug in a -1, we got 1/2 or 0.5, same thing. We plugged in 0 and we got 1. And then we started plugging in the positive numbers, right? So if I put in 1, I just got 2. And if I plugged in 2, I got 4. And then I think I plugged 3 in and I got 2 to the 3rd power, which is 8. Okay, and we'll stop there. So what we want to do now is we want to sort of connect the dots, right? We want to take all those dots and we want to draw a smooth curve through them. And that smooth curve is going to be f of x is equal to 2 to the x power. So up here, I've got my f of x, that's my function notation. I'm going to have it equal to the base of 2 raised to the x power. So we've got a number and it's being raised to the power of a variable. That's the function that you get, that red function right there. Okay. Now you can see that it crosses the y-axis right here. So this is going to be its y-intercept. It actually never crosses the x-axis. as you can plainly see right here. So there's not going to be an X-intercept or a zero, as we like to call it, because there's actually a horizontal asymptote, right? And that horizontal asymptote is going to be y equals 0. So I'm going to graph y equals 0 down here and show it to you. And we're going to make this a blue dotted line. Perfect. Okay, so now you can see that the red function is getting closer and closer to that blue dotted line, but it never actually crosses, because you can always keep zooming in and seeing that it gets closer and closer to that asymptote, but never actually crosses. So that's why it doesn't have any x-intercepts. It does have a y-intercept though. It's right here, 0, 1. Okay, so that's what an exponential function looks like. Now what we're going to do is we're going to graph our logarithmic function, which is probably something you haven't done yet, but we're going to do that together. All right, so I'm going to do a new share. Let me see if this works. All right, perfect. Okay, so back on our slide here, we're going to do the logarithmic function on the right side. Just like on the left side, we're going to have our chart with x values and y values. So we're going to draw that chart pretty close to the left side, because I think I'm going to have to. Okay. I'm going to put all the x values on the left side and all the y values on the right side. And we'll use pretty much the same numbers that we've been using so far. And what we want to do is we want to start off with the y values, I think, because this is going to make a lot more sense if we do it that way. So what are the powers of 2? The powers of 2. So if you think about it, those powers of 2 are going to be our x values, right? So starting with the powers of 2, I'm going to have 1/4. So I'm going to put 1/4 right here. And then I'm going to have 1/2. And then going in order, 2 to the 0 power is 1. 2 to the first power is 2. And then you got 4, 8, 16, and no real reason to go beyond that, I think. Okay, so on the x side, I have all the powers of 2. And on the y side, we're going to figure out what the y values are going to be. Okay? So what if we plug in those x values? Let's plug in the 1/4, for example. So we're keeping the same base, the 2, right? But we're going to replace the x on the inside with a 1/4 and see what that gives us. So this is asking, what exponent do you have to raise 2 to get to 1/4? And that's going to be a -2, if you recall. And we'll keep on going like that. So that -2 is going to be my exponent. That's my y value. So next to 1/4, I'm going to put -2. So my first ordered pair is going to be 1/4, comma, -2. Now, as we keep on going down with the powers of 2, I'm going to do this kind of quick. So we're going to have -1 right here. Log base 2 of 1, that's going to be 0. So next to 1, I put a 0. Log base 2 of 2, that's going to be 1, right? So see how I'm going in order now? log base 2 of 4. That's going to give us 2 because you need to square 2 to get to 4. And then log base 2 of 8. That's going to be 3. That's my exponent, basically. And then log base 2 of 16 is going to be 4. Okay. So now we've got a couple ordered pairs that we can graph, and we can really see why the function is shaped the way it is if we use these ordered pairs correctly. Okay. So that's going to be my chart. I'm going to go to my graphing calculator, and we're going to plot these points on the XY plane. So let me do a new share. Yeah, there we go. Okay. There we are. Okay, so now you can see our previous function, 2 to the x power. We're gonna get rid of all this stuff, and we're gonna graph the log function now. I'm gonna start on number 2 because number 1 is gonna be my actual function. So the first ordered pair that we found was 1/4, comma, -2. There we go. That's where that point is going to be. Then we had 1/2, -1. Close that up. Then we're going to have, let's see, what comes after that? 1, 0. There we go. Notice that crosses the x-axis, so that's my x-intercept. And the next ordered pair is going to be 2, 1, I think it was. There we go. That's my green dot. And then we had 4, 2, I think. 4, 2. Yep. And then we had 8, 3. And then 16, 4. We probably won't be able to see that point unless we zoom out. Okay. Now, I'm actually going to do another point just to show you how the asymptotes work with this one, because this one is going to have a vertical asymptote on the y-axis, also known as x = 0. But the next point I wanted to graph was 1/8, -3, because I think that's going to be a point. Yep. And then we're going to have 1/16, -4. Okay, so now you see how the function is starting to behave. As the function gets closer and closer to 0 on the x-axis, as it approaches the y-axis, it starts going crazy down, actually. And let's do the function first, and then we'll graph the vertical asymptote. So scrolling on back up here, for number 1, we're going to graph g of x is equal to log base 2 of x. Now, it's kind of hard to graph this because it's not really simple how to do it. You actually have to go down to the keyboard, which is down here in the left-hand corner, and you have to do this for all the log functions. What you're going to do is you're going to see where it says functions on the right side. You're going to click that, and then we're going to find the log function because it's in this list somewhere. Yeah, it's under miscellaneous. Okay, so down here, we have ln, which we're not going to choose because that's the natural log. We also have the log base 10, also known as the common log. We're not going to choose that. we need to choose a logarithm that's going to give us a custom base. And the base that we need is 2. So now I do the 2, and then I put the variable x inside the parentheses. And that's going to give you that function that you want. Okay, so now you can see what a log function looks like. It has a vertical asymptote at x equals 0. So what I'm going to do is I'm going to go down here. I'm going to type in x equals 0 because that's going to be our vertical asymptote. And I'm going to make it a blue dotted line because typically that's what I do for all asymptotes. Good. So now notice that the function gets closer and closer to that blue dotted line, but it never crosses, right? That's because it's an asymptote. The values get progressively and progressively negative. Because even if you follow it down like this, it looks like it might cross, but you've really got to zoom in a little bit more. And what you find out is when you zoom in, it never actually crosses the blue dotted line, no matter how far down you go. So let me return to my default zoom. So that's the logarithm function. And if you follow this function all the way to the right, this function is actually going to go up and up very slowly, but there's never going to be a horizontal asymptote. It's always going to be a vertical one. So if you think about it, that's kind of the exact opposite of the exponential function that we graphed earlier, that 2 to the x power. It had a horizontal asymptote, but logarithms always have vertical, right? So this function is just going to keep on going up to positive infinity on the right side. So that's the end behavior. Okay. Let me pop on back over and let me do a new share so we can kind of zoom in on this. Okay. So that's my exponential function and my logarithmic function. They are inverses of each other. And what that means is you can cancel out one with the other. And we also learned that on Monday. Okay. Now what we're going to do is we're going to talk about the problem set and the classwork on the next page. So I'll leave that up there for a little bit, and then we'll move on to the next thing. Okay, so I actually don't have the problem set with me today because my printer ran out of ink. That's a problem, so I'm actually only going to be doing the classwork problems. So for the classwork, I think I made a video about that. I put it on the module, and I can't remember which numbers I did. I either did the odd ones with you or I did the evens with you. I think what I'm going to do is I think I might be able to do them all, depending on time. Or at least I can show you how the odd ones work. Yeah, I think that's what I'll do. Okay, let's move on to the next slide. And we're going to be looking at the classwork. Okay, let's do number 1. Number 1 gives me f of x is equal to 1/2 raised to the x power. And it says for each function, you want to find 7 things if they really do exist. And we'll talk about that a little bit later. Okay, so this is an exponential function. And for the first question, it asks you to find the parent function. And the parent function is just going to be y or p of x is equal to a to the x power, where a is the base. So that's going to be the parent function. We can also write it like this. We can say that it's an exponential function. That's how I would describe it in words. So it's an exponential function. Okay. Now that a is going to be the base. It's just going to be a number. So in this case, a is going to be 1/2. A is 1/2. So when we graph this, this is actually it's going to be looking like, it'll be looking very similar to the 2 to the x power, but it'll actually be flipped around the y-axis, I think. Yeah. It's going to be exponential decay instead of exponential growth. But we'll take a look at that a little bit later. The next thing it asks for is there a transformation? So is there any transformation that's going on? For some of these problems, there are, but for this one, there are no transformations. So we don't have to worry about that. There's no dilations or reflections or anything like that. So that's going to be part A. You're going to find the parent function and the transformation. Okay. Let's do part B now. What is the domain of this function? So the domain is going to be the set of all x values. The set of all x values. And if you recall, for these types of functions, x can literally be anything. So the domain is going to be all real numbers. All real numbers. You can write it like this. You can write it as a capital R, or you can write it in interval notation, which would be -infinity to +infinity. Every single x value is going to have a y value. So all the x values, the negatives, the positives, even 0, they're all going to be used. And we'll see that when we graph it. Okay, let's do part C now. What is the range of this function? Well, if you were to actually graph this, you would see that the graph only takes positive y values because there's a horizontal asymptote, right, at 0 on the x-axis. So it never actually hits 0 or any of the negative numbers. So the range can be written as y is greater than 0. And you'll see how that works when we graph it. So you could say y is greater than 0, or you could say 0 to +infinity, since the y values are only going up from 0. And so those are the two ways that you can describe it. I guess you could also write it this way. Y is between 0 and +infinity. Okay. What about the vertical asymptotes? Vertical asymptotes. We'll do horizontal after this, so we're going to be talking about both types. Are there any vertical asymptotes? Not for these types of functions, so I'm going to write none. You will see them on the log functions, though. That's true. All right. Now, what about the horizontal asymptotes? This one has one of them. This one has a horizontal asymptote on the x-axis, which is y equals 0. So you could say y equals 0, or you could say x-axis, because those are two answers that mean the same thing. Okay, let's do the last two parts. We're going to be finding the x-intercepts. And then over here for part G, we're going to be finding the Y-intercepts. Actually, what I'm going to do is I'm going to put this a little bit closer. Okay, so if you were to graph this function, what would its x-intercept be? Where does it cross the x-axis? That's a trick question, right? It does not cross the x-axis because we have a horizontal asymptote there. So there are no x-intercepts. I'm going to write none because there are none. Okay, what about the y-intercepts? Where would it cross the y-axis? Well, if you want to find y-intercepts, you just have to let x be 0. Let x equal 0 and go from there. So we're actually going to be finding f of 0. I'm going to take the entire function and I'm going to let x be 0 to see what happens. Okay? Because when the x values are 0, you're on the y-axis. Keep that in mind. Okay, so when we do that, we're going to get the number 1/2 raised to the x power. So it's going to be raised to the 0 power. So I'm going to get 1/2 to the 0 power, which is 1. So if I was to write this as an ordered pair, what I would do is I would put the x value first, which we assume to be 0, and we're going to put our y value as 1. So that's going to be the y-intercept. Okay, so I'll give you guys a minute to copy this down, and then what we're going to do is we're going to graph this on Desmos, and we're going to confirm everything. So the domain and range are going to be exact opposites when we look at exponential functions and log functions, because they behave very differently, even though they are inverses of each other. One thing I'll say about the domain is it's always going to be all real numbers when you're dealing with exponential functions. But when you look at the range, it's going to be y is greater than 0, or, you know, wherever your horizontal asymptote is. And we'll talk about that a little bit more in depth a little bit later. Okay, so let's go on over to Desmos. Let's see if I can do a new share. Good. All right, there we go. I'm going to get rid of all this stuff by hitting the X's. So many. Okay, so what was my function? F of x is equal to 1/2 to the x power. So I'm going to raise this up to the x power. Okay, and that's what our function looks like. Notice that it's falling as you go to the right. The function is always falling. So that means it's always decreasing on all real numbers. We can say that this is an example of exponential decay. Whereas if you were to graph 2 to the x power, that would be exponential growth because it's increasing as you go to the right. So that's how the black function is exponential decay and the red function is exponential growth. And it all depends on what your base is. If your base is greater than 1, then you're going to have growth. If your base is between 0 and 1, like 1/2 is, you're going to have that decay. Okay, but just looking at this function, the domain is all real numbers because as you zoom out, every single x value is going to be represented here, even the really negative numbers. So every x value is going to have a y value. But what is the range? What y values does this function take up? Y is greater than 0, right? And if I was to graph y is greater than 0, it would be every single ordered pair that's above the x-axis. So that's what this function takes up as its y values. Okay. Another thing, vertical asymptotes, it obviously has none. Horizontal asymptotes, remember we had y equals 0. So I'm going to graph that, and I'm going to make it a dotted line. Perfect. So the graph actually never crosses this line. Okay. The last two, the x-intercepts, remember it doesn't cross the x-axis, so there's none of those. But for the y-intercepts, where does it cross the y-axis? Right here, 0, 1, just as we predicted. And remember, the only thing we did with that was we let x be 0, and we just saw what happened. So that is my y-intercept, where it crosses the y-axis. All right, so let's move on back. Let me do a new share. There we go. All right, and that's number 1. I'll leave this up there for a little bit, and then we'll try number 3. Then if we have enough time, we'll look at the evens. We could do those pretty quickly. Okay, let's do number 3. Okay, so 3 says f of x is equal to log base 2 of x plus 1. So we've graphed this before with a base of 2, but the only difference is we have that plus 1 added on to the side. So what's the parent function? The parent function is going to be y equals log base b of x. That's called the logarithmic function. That's what I would say is the simplest type of logarithm, where you just have a base and you have your x. Now in this case, our base is going to be 2. So b is equal to 2. Okay. Is there any transformation? Yes. What does this plus 1 do? Do you remember? If I add 1 to every y value, what happens? It goes up, right? So if we add 1 to the end, that means it's going to go up 1 for all ordered pairs. Okay, so that was part A. Let's do part B. What is the domain of this function? Well, you can never let the x values be 0. You can never let them be negative either. So I'm going to say x is greater than 0. And you'll see proof of this once we look at the graph, because it's actually going to have a vertical asymptote at 0. And that's why x can never be equal to 0 or equal to a negative number, because log base 2 of a negative number, like -4, is undefined. And we'll see that when we graph it. Okay, what is the range? The range is going to be all real numbers. All real numbers. You'll see that when we graph it. Okay, vertical asymptotes. There is a vertical asymptote. It's going to be at x equals 0. I'll show you what that looks like later. For horizontal asymptotes, it's not going to have any because it doesn't behave like an exponential function would. So I'm going to write none. Okay. What about x-intercepts? X-intercepts. Does it have any? Also, y-intercepts. Y-intercepts. Let's do the x-intercepts first. So you could look at a graph to get this. What you could also do is you can set the whole function equal to 0. So we're going to set f of x equal to 0. And what that means is I'm taking the entire function, log base 2 of x plus 1, and I'm setting it equal to 0. And I'm going from there. So my x is actually going to be a solution to this equation. The first thing I'm going to do is I'm going to subtract 1 from both sides. That's going to get rid of these 1's. 0 minus 1 is negative 1. And I'm left with log base 2 of x. Now, to get rid of a logarithm, what you have to do is you have to introduce an exponential expression. So the base for both of the sides is going to be 2, but the exponent is going to be log base 2 of x. And the exponent on this side is going to be the negative 1 that I found. Okay, so over here, the 2's are going to cancel out. I'm left with x, and 2 to the minus 1 power is actually going to give me 1/2. So I'm going to get 1/2 comma 0. Yep. Okay. Y-intercepts, where are the Y-intercepts? There are actually no Y-intercepts, so that's going to be none. Why is that? Because the y-axis is the vertical asymptote. So let's graph it and take a look at it. And we can confirm all this stuff by using the graph. Okay. Okay, so here we are on our graph. We're going to have f of x is equal to log base 2 of x. I actually need to get the logarithm function, so I'm going to go down here to functions and get my log base 2. My x goes on the inside of the parentheses, and I have a +1 on the outside. So that's going to take all the ordered pairs and move them up by 1. Okay. And I'm going to change the color to black. So this is my function. Notice that it has a vertical asymptote at x equals 0. I'll change that to a dotted line that's blue so you can see it a little bit better. That graph is not going to cross that line. So when we talk about the domain as a set of all x values, can't you see how the graph is never going to take 0 as an x value, or any negative number for that matter? That's why the domain is x is greater than 0. And the range is all the y values, right? That's going to be all real numbers because the graph goes all the way down on the left side, and it goes all the way up as you get to the right-hand side. So it's actually just going to keep on going up if I zoom out. It'll take it a little bit longer to do it, but it will. So that is my function. Now let's talk about the intercepts because we haven't talked about those yet. Does it have a y-intercept? No, it does not cross the y-axis, right? So we're not going to be doing any y-intercepts. How about x-intercepts? Where does it cross the x-axis? That's going to be right here. See how it crosses at 0.5? That's going to give you that 1/2 that you want. X equals 1/2. And since the y value is 0, that's what makes it so that it's always on the x-axis. Okay. Let's do 2 and 4 real quick. I think I got like 20 minutes left. So let's go to our chalkboard. And let's zoom in on that. Okay, so that was number 3. Now let's do the even ones. Okay, number 2. 2 gives me g of x is equal to 2 to the x minus 3 power. Now this one is an exponential function. So it's y equals a to the x, where a is going to be 2 this time. And another thing we can say about it is it would be called an exponential function. So let's write that down. Exponential function. Does it have any transformations going on? Actually, yes. What does this minus 3 do? What does the minus 3 do? It's not going to take you down 3. It's actually going to take you to the right 3. And the reason for that is it's because the negative 3 is with the x value. It's not off to the side like it would be right here, right? These two functions are totally different. This one would be down 3. But since this negative 3 is with the exponent, it's close to the x value, I would say. So this is actually going to be going to the right by 3. And that was part A. Okay, let's do domain. Domain is going to be all real numbers. All real numbers. How about range? Now it's going to have a horizontal asymptote, so it can't go below 0. So the range is going to be y is greater than 0. Okay, vertical asymptotes, none. Not for exponential functions. You will have them for log functions. Horizontal asymptotes, yes, y equals 0. Also known as the x-axis. X-intercepts doesn't cross the x-axis, so none. And then the last thing is the y-intercepts. Now for the y-intercepts, what you want to do is you want to let x be 0 and see what happens. So if you let x be 0, what happens? You get g of 0. So I replace this x with a 0. And when I do that, I replace the x with a 0. So I get 2 to the 0 minus 3 power. What would that be? Well, 0 minus 3 is the exponent. We know that 0 minus 3 is negative 3, right? And then 2 to the negative 3 power is 1/8. So that's going to be the y-intercept. 0, 1/8. Okay. So I'll give you guys a minute to copy this down, and then we're going to look at the graph and its shape, and we'll verify all this stuff. So that is number 2. That is my exponential function. Okay. All right, so now we're here in Desmos once again. Let's graph number 2. I've got g of x is equal to 2 to the x minus 3. Actually, I need to put that with the exponent. So We're going to do parentheses up here. There we go. Now I got it. Okay, so what you'll notice about this graph is it's actually moved to the right by 3. You can kind of tell because usually it crosses the y-axis at 1 up here, but that point is over here now. So this graph really did move to the right by 3. That's what that x minus 3 means. Okay. Domain is all real numbers. The range is only going to be y is greater than 0. So you're never going to have a y value of -50, right? The function just doesn't go down that low. It doesn't even hit 0. That's going to be the horizontal asymptote, y equals 0. So the function gets closer and closer, but it never actually crosses. And then we did y-intercepts. That's going to be right here. 0, 1/8. Also known as 0.125. Same number, just written as a decimal. Okay. Let's move on to the next one and we'll finish this up. Okay, so that was number 2. I'll leave that up there for a little bit. We're going to be doing number 4 next, and that's going to be a log function. Now, this next function is actually going to have a base of 3. So we'll see what happens to the function as we change the base from 2 to 3 and from 3 to 10. And we might even look at the natural log. That has a base of e, Euler's number. All right, let's look at number 4. Last one on the classwork. So this one is g of x is equal to log base 3 of x plus 2. So we know right off that the parent function is going to be y equals log base b of x. But this one has a base of 3, so we say b is equal to 3. We know it's a logarithmic function. I mean, it has the word log in it, so that's pretty obvious. So that's the parent function. What is the transformation, if any? How about this plus 2 right here? That's going to make it go to the left by 2. And we'll see that when we graph it. Okay. Domain. This is kind of tricky. What we're going to do first is we're going to figure out what the vertical asymptote is. But my range is going to be all real numbers. All real numbers. That's going to be the case for every log function. Okay, vertical asymptote. So what we're going to do to find vertical asymptotes is we're going to set the insides equal to 0. So what we're going to do is we're going to take this x minus 2 that's on the inside and set it equal to 0. And I explain why I do this in the vertical asymptote video. You basically don't want to take the log of 0. And if x plus 2 is actually 0, that's going to give you that x value that you can't cross. So I'm going to subtract 2 from both sides. And that's going to give me -2. That's my vertical asymptote. So we're going to be taking all the x values that are to the right of -2. So for the domain, we're going to be looking at the set of all x values. So I'm going to use the variable x, and all the x values have to be greater than -2 for this to work. Okay, horizontal asymptotes. Are there any? No, not in log functions. Now, are there x-intercepts? Maybe. Let's see if we can figure out what they are. So for the x-intercepts, I want to set the whole function g of x equal to 0. So if I set the entire function equal to 0, I'm going to figure out very quickly what x has to be for this to work. So we're going to take log base 3 of x plus 2 and set it equal to 0. Okay, so to get rid of a logarithm, you have to raise both sides to a base of 3. So you're going to have 3 to the power of log base 3 of x plus 2. And all that's going to do is it's going to make the x plus 2 come out. But I also have to do the same thing on the other side. So the base is 3, 0 is my exponent, because I have a 0 right here. Well, 3 to the 0 power is going to give me 1, and the x plus 2 is going to come down. The bases actually cancel out. So now what you want to do is get x by itself. We can subtract 2 from both sides. So let's do that. We get x is equal to 1 minus 2, which is -1. So -1 comma 0. That's where it crosses the x-axis. Okay. Now let's do the y-intercepts. So for the y-intercepts, it's going to be a little bit different. And I'll do this right here. So for the y-intercepts, what you want to do is you want to set the variable x equal to 0. And we'll figure out what happens when we do that. We get g of 0 is equal to log base 3 of 0 plus 2. Okay. So we're just letting x be 0 at this point. And then what's 0 plus 2 going to be? That's going to be 2. So I get log base 3 of 2. Now, there's not really a good way to express this as a whole number. You actually can't do that because you're actually looking at what exponent you have to raise 3 to get to 2. And that's very difficult. So we're going to keep this as a log expression. So log base 3 of 2. So this will be an interesting one to look at. So I got 5 minutes left. Let's quickly go over to Desmos. Okay. So our logarithm is g of x is equal to log base 3 of x plus 2. And there's our function. Now we know that the vertical asymptote is going to be -2. I can already see that. So I'm going to type in x is -2, and I'm going to change it to a dotted line. So that green function will never cross that blue dotted line. The x-intercept is -1 comma 0, just as we predicted. And our y-intercept is going to be 0.631. That's going to be that log base 3 of 2. So real quickly, let's figure out what that decimal is. I'm going to get the log base 3 back again, and then put 2 inside here. And indeed, that does give me that 0.631 that I was looking for. So that's a way you can figure it out if you don't have a whole number that you can judge from. Okay. And that's it. I'll go ahead and go on back to number 4. And let me zoom in on it. And there we go. That's number 4. Okay. So what are you going to be turning in on Sunday? Your equations classwork, your functions classwork from today, and then the extra credit, which is optional if you choose to do it. All right. Class dismissed. Hope you have a great weekend and a great spring break. I will see you the week after next, I think. And we'll be getting started on function compositions and inverses, which is actually kind of fun, I think. So see you guys later. If you have a question about today's lecture or the classwork, go ahead and throw them down in the chat box, and I will get to you very shortly. Okay? Have a very mathematical day.